Welcome back. Now that you're familiar with the amplifier and USB audio adapter in your Level C kit, let's switch gears to look at audio software commands that will also be useful. In this final video for the lesson, we'll be looking at software audio functioning, including specifically the arecord and aplay commands. We'll then switch gears briefly to learn about the OS module, which allows us to run CLI commands from within Python. Recording and playing audio from the CLI is fairly simple, with a couple of commands called arecord and aplay. And as the name suggests, arecord is used to record audio, and aplay is used to play audio files. So let's start by talking about the arecord command. So to record audio, you'll need to figure out the location of your USB capture device. This location will consist of a card and device number. Luckily, arecord has a handy option, and it's -L. And that can be used to list all available recording devices on the system. So the full command is arecord -L, and the output looks something like you see here. So in this example, it looks like there's only one capture device found on this system, and its location is card 1, device 0. Okay, here are some of the options that must be specified when using the arecord command. The first one, that device option you see there, that just says the record input from the device at this location. So just record the input, leave it in this location. Okay, next up we have format. That one is to recorded format will be signed 16-bit audio. Next, rate 48,000. That just means the sample rate will be 48,000 hertz. And then we have C1, which just tells it to record only one channel. That's also known as mono. And then finally, we have test.wave, which is the file name we're telling it to use for the recorded file. So if you look at all these commands and the options assembled into a single line, you get what you see here at the bottom of the screen. So running this command in the directory /home/pi will save a new file named test.wave to the /home/pi folder. Now the recording will start as soon as this command is executed, and a message with recording information will be printed to the console. When you're finished with your recording, you can use the Control-C keyboard shortcut to end the program. The aplay command also has a -L option to list all available playback devices, but a card or device number is not required to be specified when running the aplay command. If no device is specified as option, then aplay will play sound through whatever output device is selected in the upper right status bar, and this makes it a lot simpler to run the aplay command. This command will play the file named test.wave from the current working directory through the currently selected output device. You could also specify the full file path so you can play sounds that are located in another folder like you see here. This would allow you to be, say, in /home/pi, but play a sound that's located in /home/pi/desktop. You would run this command from any directory in the system, and aplay would still play hello.wave from your desktop. So before we finish up this lesson, let's talk about a completely different concept. The OS module in Python allows you to run CLI commands from within your Python program. This can be really helpful when you want to do something in Python that normally would only be done on the CLI. So importing the OS module can be done just like any other module. That has to be done at the beginning of your program, so the OS module will be available throughout the rest of the program. The OS module has many functions, but you will mainly be focusing on its os.system function like you see in the second code box. This is the function that allows commands to run as if they were typed into the CLI. Anything placed between those double quotation marks will run as if typed into the CLI, and in this case, some command would attempt to run on the CLI. I'm very creative today. Some command. Okay, and then in the last code box you see here, this is a practical example. The command in the third box will use the aplay command to play test.wave from the /home/pi directory. You can also string multiple os.system commands together like you see here. So in this program, a wiring pi command is being used to switch GPIO 18 to a PWM pin that will contain the left audio channel. Aplay will play the file test.wave from the desktop, and another wiring pi command is switching the GPIO 18 back to its default state as an input. So as you can see from this example, the ability to execute CLI commands from within Python programs definitely opens up some new possibilities to explore in upcoming projects. Okay, before you move on to the activities, let's take a few moments and review the concepts we've discussed over these last 3 videos. Different size speakers require different levels of amplitude, and an amplifier can take a small signal and make it much larger and appropriate for driving larger speakers. Amplifier gain is the amount of amplification, and some small amplifiers like the one in your kit can be adjusted using the potentiometer on the front of that circuit board. Distortion occurs when the driver signal is too large for the connected speaker. So just a small amount of distortion might just sound like the sound's being degraded, but heavy distortion can actually damage the speaker, so you want to be careful of that. Your kit includes a PAM 8302 amplifier with input power that runs from 2.0 volts to 5.5 volts. When attaching it to a speaker, you'll want to be sure that the speaker's impedance range is between 4 and 8 ohms. That's also very important. Your Pi includes a 3.4 millimeter headphone jack that can be used to output signals. And I'm sorry, it's a 3.5 millimeter headphone jack that can be used to output audio signals. So this is like the standard headphone jacks we think of. If you're planning on attaching your Pi to a TV or computer monitor with built-in speakers, audio output is also available using that HDMI connection. And just a quick reminder that most computer monitors do not have built-in speakers, so don't be surprised if you don't hear anything. Your kit does include a USB audio adapter, but if you have another external USB audio device available, just be sure to check that list of compatible options to make sure there's driver support for that device available through the Pi. We also walked through the option of using GPIO pins for audio output, and in terms of audio input, the Pi doesn't have a built-in capability for something like a mic, and so the USB audio device in your kit will come in handy there. We also looked at software audio functions, including the arecord and aplay commands, and then finally we shifted topics and talked through the OS module, which allows us to run CLI commands from within Python, which is a very handy module. You're going to learn to love that one. All right, go ahead and move on to the activities for this lesson, where you'll get a chance to work with the amplifier and speaker, including recording and playing audio files.